heritage hardware always sounds good. It's being built or has been built before. You get over your development, your DDT&E stuff is behind you. There's a lot of advantages why someone would want to use heritage. But to take a heritage piece and integrate it into a new system, the physical integration and technical integration, is as much work as if you started off from scratch. Sometimes it's more work than if you started off from scratch building something new, because you have what was done for development and for verification, 10, 20, 30 years ago. So the magic, if you will, for 1X was stitching together new hardware, new processes, old processes across these centers that aren't used to working together, and finding a way to get it to work.
One of the lessons that we learned relative to using heritage systems is that as good as they are, and in many cases they save you from developing things, you are then constrained, unless you do additional analysis or test, to the environment and operational or performance environment that they're used to operating in. And so there's good parts to it because you don't have to re-engineer them. In many cases, they're available to you. But in most cases, you have to do additional testing, and you have to do a lot of additional work to make sure that you are within the spec of that, the environmental spec. So we ran into issues with this. I think it shortened overall by far the length of time to develop the Ares 1X, but I also think that it added some complexities that we had not anticipated.
One of the things that we ran into on Ares 1X was the use of heritage hardware. Now that sounds really good. We're going to go use heritage. This stuff has been proven, it's flown, so we're just going to go take that off the shelf and we're going to go use it. What you save is all that original design and build time. What you don't realize is that now you've got new integration and new loads that this stuff all has to be certified to. So while you do save yourself some time up front, you may not have thought when you heard the word heritage hardware that it was going to cost you anything. It was just going to, it's almost like it's a freebie. We get this and now we're just going to go use it. But now you've got to do totally new integration. It's seeing new loads, new dynamics, all that sort of thing. So I think a lot of us got lured in up front, got hypnotized by this heritage hardware, and we didn't think about that. But as we found out as we go along, okay, well, you've got for example, let's say you got first stage, which is, it's just a solid rocket booster. We're just going to go use that. It's flying a whole new flight regime. It's got completely different loading. We added some hardware to it here and there. And when you do that, you've got to go do all that analysis. And so you don't say, in fact, it may cost you a little bit more because now you got to go back and find some stuff that you did before that's hard to find. And you're trying to adapt it. Well, if it saw these loads, it might have been easier just to act as if it were a clean sheet of paper for a lot of that sort of stuff. So we got, I would say, lured in up front that just using heritage hardware was going to be all fantastic and no cost to it at all, and we were wrong. So heritage is great. I recommend you go use it, but make sure you plan up front. Down the road, it's going to require you extra verification time.
I've gone to lessons learned class a couple of times now, and that is in every lesson learned class that I go to about utilizing heritage hardware and not treating it as a brand new design. And so it's almost it's good to use it because you know a lot about it. And so that's what's good about using heritage hardware, is because you do know some things about it, but you need to not try to just settle on it's going to behave in the same manner as I'm used to it, or it's going to operate in the same manner as I'm used to, because it's not. It's going to be a new design. It's going to operate differently. It's going to handle different. It's going to have different characteristics, and you need to be aware of that, and you need to anticipate that and do more on anticipating it.
Part of on ground systems, or why we saved a whole lot of money and a whole lot of time, was we leveraged to the maximum amount the use of existing facilities. So in that case, the launch pad, the mobile launcher platform, and the VAB. So as we took over these assets from the shuttle program, it was important for us to go and ensure that what our designs, what we had been designed to, were going to match up with the as-built for those different assets, because we were using systems in some cases had not been touched since the beginning of the shuttle program, and for some even prior to that had not been touched since the Apollo days. Was going out and doing surveys of the different ground systems to see how well they met with drawings or specifications that we had. One catch was out the launch pad. What we had found out is very early on the shuttle program, they had to fix a misalignment between the doors of the orbiter as they opened and the payload changeout room. They had lowered the jacks for the mobile launcher platform out there, which basically took the whole shuttle stack and lowered it. So as we were surveying, we found this discrepancy between how we were going to stack the vehicle at the VAB and how it was going to line up on the pad. We found it in enough time to where we could go adjust and move items out of the pad such that we could continue to provide the access, the ECS, the environmental control, and grab onto the vehicle with our stabilization system. So big lessons learned is don't trust the drawings that you had, especially the ones that are very old. Go do those additional surveys to verify that your drawings, that your models are accurate and up to date, that something hasn't changed in the interim.
Yeah, another challenge you use when you're using heritage hardware is not only for that piece of hardware itself. That itself may be able to show this particular box or widget may serve the function that it needs to serve. But the hard part about heritage is everything else that needs to change in order to accommodate that piece of hardware. A good example we have for Ares 1X is early on we had a desire to fly, we call it motion packs, basically these sensors that go on the outside of the vehicle that are little rate gyros. So as the vehicle is flying and you have 7 or 8 or 10 rate gyros on the outside, you can get a feel for how the vehicle is bending during flight. Very interesting data. Typically don't do that, so for a flight test vehicle, it would be good to go. So we had people who were knowledgeable of the sensor, this actual rate gyro, come to us and say, hey, this already exists. You can buy it from such and such company. We think we should go do this. It's a pretty easy solution. And that was easy enough. That was a good enough answer. That got baselined into our measurement list, that we would fly these kind of sensors, across the vehicle. That was the easy part. The hard part was the fact that if you're on the first stage, you have to mount it on the outside of the vehicle to a steel can that has propellant inside. You can't drill holes through it or anything like that. It requires significant integration and a housing to go around it, and an isolator plate on the motor, and then a particular special voltage that ties into the avionics system we didn't have. And so the consequences or the impacts of that simple heritage part of it were so big that we had to stop and say, we can't do this. We had to delete it from our measurement list because the simple sensor that was off the shelf, which is a great solution, had a waterfall of so many big impacts to the overall system that we were going to spend way too much time and money trying to do that. So to me, the integrated effects of a change, with heritage, the best way to treat heritage is pretend it's not. Say, here's a box. Okay, great. Whether you've done it before or used it before, chances are you're using it in a different environment, a different application, a different installation location, a different installation method. There's going to be something different about it because we always never build 2 vehicles twice. So therefore, it's got to prove itself that it can handle those environments just like every other piece of hardware that comes forward. And if you do that, you'll be safe for that piece. If you think through the integrated end-to-end from design all the way to launch day impacts of the heritage change, then you can understand whether it's really a good trade for you or not.